because they are easy, but because they are hard.
Do you remember at the beginning of the semester we worked with single matrices? We solved systems using them, basically, is what we did. Well, now we're going to cover a little bit more complex problems working with more than one matrix at a time. Now, as you may expect, as the problems become more complicated, they get way more practical and useful in real life. Let's start off with the basics of matrices and some of the basic operations that we'll do today. Okay? Remember a single matrix? Here's an example. This one, for instance, we would call a 2 by 3 matrix because it has 2 rows. We start counting at the top, remember, row 1 and row 2, and 3 columns. Now we're going to start counting those from the left. There's column 1, column 2, and column 3. There's an example of a single matrix.
You'll come again.
Let's look at, here's another single matrix. It looks a little weird, but it's still a single matrix. This one would be a 2 by 1, and we will be using these that look like this, believe it or not. As you can see, it has 2 rows. Remember, we start counting at the top and work our way down. Row 1 and row 2. And of course it has 1 column. Now remember, once again, even though we only have 1 column, we're going to start working from left to right. And that's kind of natural to do, isn't it?
Big deal.
Well, you know, you might say, well, what would I ever use a matrix for? Well, I use them all the time. Just today I was working with your grade book that had various rows that had the students' names and many columns. Some of them had homeworks that you'll be required to do, of course, and some of them had your tests. Any spreadsheet is going to be a matrix. This one, for example, is a 7 by 10 matrix. In stores, to keep inventory, many people are going to involve matrices with their work. For instance, the various columns might name various products, such as cereals. And the rows might be various stores and how many you have of each product in each store. Get the idea? I hope you can see that this matrix shows, or this graphic shows, that we have, for instance, our factory has put 101 cases of Captain Crunch at the local Safeway and 145 cases of Captain Crunch at the local Shoppers Food Warehouse, whereas it only has 100 cases of Trix at the Safeway and 198 cases of Trix at the Shoppers Food Warehouse, and so on. But the point is, to keep track of all this,
Well, look what we got here.
we have, in this example, a 4 by 6 matrix.
Oh, yes.
We might use a matrix for a price table. Of course, we'd have to name the columns and rows. In this case, the rows would be the various products, and we'd only have 1 column. So this would be a 6 row by 1 column matrix, or a 6 by 1 matrix.
It will make your life very simple, sir.
Now, we will have a need, to do what's called matrix addition.
Whoa!
You're only going to be able to do matrix addition if the 2 matrices are the exact same size. So let's take 2. We'll add this matrix, which is of course a 2 by 2, to this matrix. Now
what am I going to do?
well, I'll show you. Very simple. Just add the corresponding values to get yourself one single matrix that is the sum of those 2 matrices. The top left plus the other top left will give you the top left of your answer. The top right and the top right, you add them together and you get the top right of your answer. Very simple, isn't it? Don't forget that if we add these two, 0 can be an answer, so don't be afraid of 0. He's certainly a value like anybody else. And bottom right and bottom right, quite simply, we have the sum of these two matrices. We've actually done matrix addition. But remember, once again, they have to be the exact same size. Exact same number of rows and exact same number of columns. There's your answer. Now you may ask, what would I ever use matrix addition for? Well,
Yoink! In the way!
here's we'll go back to our inventory matrix. Okay, but this may only be the matrix for the Wheaton stores. And you may be the smart guy, so you're the regional manager. So to keep complete inventory of your whole region, you'll have to add the Wheaton matrix to the Rockville matrix to the Germantown matrix, etc. Okay? Believe it or not, in a little while I'm going to show you a quick way to use your calculator to add those matrices, because you can see this is starting to get into quite a lot of number crunching. Okay? Now, another operation we're going to have is multiplication. There's going to be two types of multiplication. We're going to do one of them today, and that's multiplying by what's called a scalar. Okay? A scalar, what does a scalar do but scale? Okay, it's going to scale
I know that, dude.
every member of the individual matrix that you're using. For instance, we may take this matrix, which is a 3 by 3 matrix, and multiply it by the scalar 4. Well, how do we do that? All we do is multiply each of the members to get an answer. I multiply that member by 4, and I get an answer. 4 times 0 is 0. Now you got to put it in the right place, of course. Okay, where's the answer for 4 times 3 going to go? 4 times 3 is 12. Go right where the original member was. 4 times 4 in this case will be in the top right, and I get 16. Very simple, isn't it? In other words, just multiply each of the members by that single scalar. 4 by a half, don't let that scare you. 4 times 0. All you have to do is make sure everything ends up in the same place. 4 times 7. 4 times 10. And 4 times 5. So that's multiplying by a scalar. All you do is multiply each and every member of this single matrix by the scalar, or the number. Not too hard, is it? I want to give you a quick example of what you might use that for. There's many things you would use it for.
Hey, this is great, man.
Suppose you wanted to raise the prices of all of your products. Well, I would multiply that price matrix by a scalar of, if I want to raise the price by 7%, a scalar of 1.07. And, of course, that would multiply every member by 1.07, and it would basically raise the price of all my products.
Hey, Doc, wait! I want to ask you something.
There's another thing we're going to have to check sometimes, whether two matrices are equal. We need to know in the future whether this matrix is equal to this matrix. Well, that's going to depend on the values of x and y. To be equal matrices, two things have to happen.
Whoa!
One thing is they have to be the exact same shape or exact same size. They don't have to be 2 by 2s, but if one's 2 by 2, the other one has to be 2 by 2. If one's 3 by 2, the other one has to be 3 by 2, etc. Okay?
A clue!
And the other thing is that each and every set of members has got to be equal. Now this member must equal its corresponding member. So I'm going to have to set x so that that works. This member must equal this member. Well, that's looking good. This member must equal this member, and this member must equal this member. Well, this won't always be true in this case. This specific example, these two matrices will only be equal if x equals, let's see, what makes 5 equal x minus 1? Well, x would have to be 6, and I'm looking at these two, y would have to be 1. Okay? So the point is, to have equal matrices, they have to be the exact same size, and all the members have to be equal. Well, now we're going to start using our calculator. So get your calculator out. I want you to work with me. I'll give you a little tour of it first, but in a second I'm going to want you to start working with me. The matrix button on a TI-83 is right here. Okay, so when I say hit matrix, it's going to have its own button for the normal TI-83. Of course, the cursor keys are here, so when I speak of the cursors, you know what I'm talking about. There's the enter key. Now, why do we need this to know about the second key? Of course, you know anything that's orange is going to be, we're going to get that via hitting second first. Okay, and we're going to be using quit. So, of course, to get quit, you'll have to hit second and then mode, and you'll get quit. So I'm just going to say quit, though, and I'll expect you to know where that is. And this is the inverse button. We're going to be able to find the inverse of a matrix using this. But when I say inverse, that's what I mean. That's x inverse. Got the idea? Now, if you have a TI-83 plus,
Well, ooh la dee da.
there's going to be a little bit of a change in that the matrix button is just above, and that's kind of logical, it's above the inverse button. So you'll have to hit second inverse to get matrix. Okay? So I expect you to, familiarize yourself with your calculator, and we're going to work our way through inserting some matrices into your calculator so we can do some calculations. Now, the basics for doing these is you're going to hit the matrix key wherever it is on your calculator, and that's going to bring up basically 3 menus that you'll cursor amongst. There'll be a menu for names. We don't have any names because we haven't created any matrices yet. There'll be a matrix for math. So we can actually do matrix math. And there'll be a menu for editing. Now, when we go to insert a matrix in the first place, it may not seem logical, but the closest one to logical is edit. So we're actually editing nothing, and it's becoming a matrix. Okay, so we're going to start off using edit, and you'll have to hit matrix and cursor to, and let me demonstrate it for you first before you try it. You'll hit matrix and cursor to edit, and we're going to try and put in a matrix that we're going to call matrix A. And when you see these little brackets, it's supposed to look like a matrix. That means that would be read matrix A, and this is what we want to insert: a 3x2 matrix that looks like this. Okay, let me show you how you'll do it. For this demo, I'm going to be using a TI-83 plus. Okay, but as I said, the only different key is going to be the matrix. Okay, I'll turn it on. Make sure it's on, of course. Okay, now I'm going to hit the matrix key, and in order to hit the matrix key, I have to hit second inverse. And as you can see, there's names, math, and edit. And in order to insert this matrix A, I'm going to have to, even though you see A, that's if A already exists, I'm going to have to cursor over to edit. And then you see all the letters again, don't you? And I will hit enter because I'm already on A. I could hit 1, I guess. And it will ask me, what is the size of this? And as I can see from my demo, right now it's set to a 1 by 1. I'm going to put in a 3 by 2. So 3, I'll hit enter, and 2, and hit enter, and nicely it's set up a little place for me to type them in. And basically all I have to do is go to each space and type it in. So I'm going to put in the top left, the 1, and hit enter, and it'll work amongst it. And hit 5 and hit enter. I could even cursor amongst them after I put in the number. For instance, I can put in a 3 here, and if I wanted to go down, it would insert it and go down. Depending on where you want to go, you can cursor amongst, so that the cursors are like little enters also. So I'll hit a 2, and I'll cursor over. Oops, doesn't like that, does it? I have to go up. Okay, and let me cursor over and put in a 3 and cursor down, and a 4, and I'll cursor up, and I've got everything in. Okay, so now it's time for me to quit out of this, and remember where quit is. So I have to hit second mode and I get quit. Now it doesn't appear very impressive, I guess, but it has remembered that matrix. Now, just for practice, I'm going to put in yet another matrix. I don't want to call it A because I'll erase my old A. So I'm going to call it B. So I would, of course, hit matrix, cursor over to edit, and this time I'm going to have to go down to B. And this one's going to be a 3 by 2 as well. It's going to be these numbers. Let's put it in. I hit matrix by going second X inverse, and I cursor over to edit. Now this time I need, you can see that A is already in there. Remember the A, it's a 3 by 2. I'm going to cursor down to B or hit 2 and enter. And it doesn't know anything about B, so it made a guess as a 1 by 1, but this one's a 3 by 2 as well. So I'll go 3, enter, and 2, enter. And it'll create a little space for me to put in my numbers, and I can move around basically using the cursor keys and enter, and I'll put them in. It'll rotate amongst them for me if I just hit enter. It's probably the easiest way to do it. Go from row to row, column to column. And 2. Okay, now I want you to put those in. So you take the time, stop the video if you need to, but I want you to put those 2 matrices in, and then I'm going to show you something pretty cool. Now remember, after you put each matrix in, you're going to have to do what I'm about to do here, is you're going to have to quit out. Remember how to quit. I hit second mode, and it quits out. But it remembered them, I promise. Now I hope you could appreciate that we could have put in way more complicated and larger matrices if we wanted to, but I'm just trying to get the concept across. Now once I've got 1, 2, or 3 or many matrices in, why would I want to do that? Because I want the calculator to do some number crunching for me. For instance, if I was, and we will in a second, hit matrix and started naming things that already exist, that's what names is for. I could use names to type in A plus matrix A plus 8 matrix B, and as soon as I hit enter, it adds those 2 for me immediately. Pretty cool. Or I could use names to put 2 times, it's kind of a scalar, isn't it? 2 times matrix A. Oh, no! And I don't have to use 2. I could use 2.29 or something, couldn't I? It would save me all kinds of work. Or something like this. I hope you appreciate that's going to be matrix A added to 2 times matrix B.
Hey man, check it out, huh?
It's really going to be powerful once you've inserted the matrices. That's why you would want to do that. Well, let's try and do these 3. Let me do them for you, and you see if you can keep up with me. Since I already have the matrices inserted, matrix A and matrix B, matrix A and matrix B, I can go into the matrix menu, second inverse. Now I'm going to start using names. So I'm going to try and put in A plus B. So I'll just hit enter because I'm on A already, and it types A. Not just any old A, that's matrix A. And I can put plus, minus, times, whatever. I'll just do plus. Now I got to go get B. So I go in the same way. Second inverse or matrix, and I'll cursor down to B and enter. And now, and I can have all kinds of matrices, add them, subtract them, divide them, whatever. But this time I'm just going to hit enter, and it's going to add the 2 and give me the answer, what it would be. This matrix, 8, 8, 3, 6, 3, 6. And if you check, son of a gun, 1 and 7, 5 and 3, it would be 8 and 8, wouldn't it? And 3 and 0 and 3 and 3 would be 3 and 6, wouldn't it? And 2 and 1 and 4 and 2 would be 3 and 6. So it actually gives you the answer. It doesn't store the answer. You'll have to store it in another matrix yourself if you want to. But you could always recreate it by hitting A plus B again. Let's do, what would twice matrix A be? Well, I'll hit my 2. And I could do times, but you don't have to do times, remember, on a TI-83. And I got to get the name of matrix A. So I go second, inverse, and there's matrix A, so I'll hit enter. I'm already on it. And that's twice matrix A. And if I hit enter, son of a gun, twice of 1, 5, 3, 3, 2, 4 is 2, 10, 6, 6, 4, 8. I hope you appreciate the power that this is going to allow you based on the matrices you put in and the values. In this case, we used a scalar. Okay, let's use both. I'm going to do A plus 2 times B. So I'll go in and get A. So I'll go second matrix, and I want matrix A plus, I want, say, I just arbitrarily picked this formula, twice matrix B. Anytime I name a matrix, I've got to go into the matrix menu and use names rather than edit. Okay, editing is for changing the actual values. Names are for referencing them. So let me cursor down. I happen to want, I hope you appreciate, matrix A added to twice matrix B. And I can hit enter. And son of a gun, I get the right values just that fast. Took a little bit of time, didn't it? Because it had a lot of number crunching to do there, but it did it for me. I didn't have to do it. Pretty cool. Okay, well.
Thank you very much for joining us tonight. We'll see you tomorrow. Good night, everybody.
You're going to go practice that, have your calculator, and go do your homework. Good luck.